Hello Pharma aspirants, welcome back to our Pharma Thunderstorm series. Today in our Pharma Thunderstorm series, we are going to learn about very simple topic, that is basics of chromatography. We know that chromatography, it is going to be a very important in the pharmaceutical analysis field, and in this you should know about what are the basic terminologies we are going to use it and what are the different types of the chromatography techniques are available. Okay, because chromatography, it is going to do the separation of the compounds in a given mixture. Okay, so based on the polarity or based on the type of the mobile phase we are going to use, there are different types classifications of the techniques are available in the chromatography. Let us see major things need to remember while dealing with this chromatography. That means basic terminology techniques. Let us focus on this today's session. Okay, so in this Pharma Thunderstorm series, first of all we should know about the terms related to this chromatography. Means we know that chromatography has been erased based on the evolution technique that was done by the Sweat scientist. Okay, different types of the colors he has observed, majorly in the paper chromatography he has done that. And chroma means generally it is a color, and graphene means to write. Okay, so wherever we are going to get the types of the peaks, so that is called as chromatogram, whereas the technique we are going to deal, that is called as a chromatography technique. Okay, chromatography technique means it is used to separate a mixture of the compounds, and with the help of the any standard compound or reference compound, we are going to identify the compounds also. Okay, so for that purpose we are going to use some of the retardation factors, retention times, all these things we will take into that. And chromatography technique, wherever we are going to use this, that means the process of this chromatography, actually it is a separation of the mixture of the compounds, and whenever we are going to see a different distinct type of the compounds are there. Okay, a mixture may contain different types of the compounds. So the basic idea of this chromatographic process is the distinct compounds have the different properties like absorption, solubility or affinities, or otherwise exchange of the ions it is going to take place. And some of the compounds will have affinity also towards some of the stationary phases. Okay, immobilized stationary phases we are going to use it, and all these characteristics will guide us to select which type of the technique we have to use it. But absorption, partition, solubility, all these terms are going to be most important, and whatever the mechanism we are going to use it. Okay, ultimately our aim is in order to separate the mixture of the components, and majorly for separation process we are going to use the phase that is going to be called it as a stationary phase, and we are going to use the mobile phase in order to elute those compounds. Okay, the sample may contain 10 to 12 compounds or 50 compounds also. By taking a suitable stationary phase and mobile phase, ultimately we are going to separate the compounds and we are going to identify the compounds in a complex mixture. Okay, that is called as a chromatography. That is a basic term, we are going to use it. Now let us see what are the different terminologies come across in this chromatography technique. First of all, let us see the components. Components means in this chromatography techniques, we are going to use the three different types of the components. Majorly first thing, that is mobile phase, second one stationary phase, third one supporting medium. Okay, so these are the most important things. And mobile phase means a solvent, generally liquid chromatography we are going to take it, means the mobile phase, it is going to be a solvent that flows through the supporting medium. Okay, that either could be a stationary phase, that could be a solid, or a liquid coated on the solid. Okay, so that is called as a mobile phase. And stationary phase, what is stationary phase? A supporting medium will be there and a layer or a coating on this supporting medium, whatever it is there, whichever it is, a solid, or sometimes a coating means it could be a solution also. So that interacts with this analytes, okay. So that means that retains those analytes, that is called a stationary phase. Stationary phase means that is fixed, it won't move, whereas mobile phase means it will move, okay, mobility will be there. And what is called supporting medium? Supporting medium, it is going to be used in case of both adsorption chromatography as well as partition chromatography also. What it means a solid surface on which the stationary phase it is going to be bound or coated. That supporting medium, it is going to be used for preparation of this liquid stationary phases, okay. So all these are going to be called as components of the chromatography. These three are very, very important in any type of the chromatography technique. Now let us see what are the basic terms in all these chromatography type of the techniques. First thing you should know about that is adsorption chromatography, okay. Adsorption means the interaction of the solute molecules with the surface of the stationary phase. That means just now we have seen what is stationary phase, what is supporting medium, okay. So whatever the surface of the stationary phase, it is going to be there. If that is a solid, then the interaction of these solute molecules which are present in our analyte, which are going to be adsorbed on the layer of the stationary phase, then adsorption, it is a phenomena, it is going to occur. Then how we are going to elute those analyte molecules? By using a mobile phase. In this case, the mobile phase, it is going to be called as the eluent, okay. So it is going to elute the analyte molecules. So the entire process we are going to call it as elution. What is elution? The motion of the mobile phase or the mobility of the mobile phase through the stationary phase. So the process, it is going to be called as elution by using the mobile phase, which is called as eluent, okay. So these are the basic terms, generally we are going to use it in the chromatography, and it may require most of the time. That's why some of the techniques are going to be very, very time taking process are also in chromatography, okay. We require more patience also. For example, in high performance liquid chromatography, it is also called as high patience liquid chromatography because it takes much time in order to separate the compounds. And the time taken for the separation of the compounds, it is called as elution time. What is elution time? The time taken for a solute. Generally, the solute means different n number of solutes are going to be present in a given mixture. The time taken for a solute to pass through a system, once we set the run time and everything, the process, okay, for the elution process, then the time taken for the solute particles to pass through that system, it is called as the elution time. So a solute generally with short elution time travels through the stationary phase very, very rapidly. That means it leaves the stationary phase very fast. Then we can call that as the elution time, it is going to be very less, okay. So like interactions, if it is there, then the retention could be more. If the solute, it is not relevant to the stationary phase, the nature of the solute, it is also different with that of the stationary phase, then it is not going to retain on the stationary phase, okay. So for that you are going to see very, very less times, in very elution could be very fast in such cases, okay. Next term, if you see the stationary phase, already we have seen, that is the whether it is going to be a solid phase or a liquid coated on the supporting medium. So in this, the stationary phase, generally we are going to call it as the part of the chromatography system that is fixed in one place. That means it is not going to be moving, it is just fixed in a one place, stationary, it is going to be call it as, okay. So let us see the another term, major mechanisms, that means mode of the chromatography techniques we are going to use. All these stationary phase, normal, mobile phase, elution, everything is going to be common in all types of the chromatography techniques, and in this we are going to use different types of the mobile phases and stationary phase in different modes. Let us see what are those modes. First of all, if you see the normal phase, what is called the normal phase mode in chromatography. Okay. Here if you talk about the stationary phase and the mobile phase, in normal phase mode, the unmodified stationary phase, okay, that means whatever the supporting material it is going to be there for the purpose of using as a stationary phase, okay, that material it is unmodified, it is as such we are going to use it. That unmodified stationary phase we are going to use, that phase it is going to be majorly used to separate the polar solutes, the solute which is polar in the nature, okay. Generally that in order to retain those polar molecules, we are going to use this normal phase mode, okay. In this normal phase mode, what we are going to use, unmodified stationary phases are going to be used, and which are going to interact, the unmodified stationary phase are going to interact very strongly with the polar solutes, because the stationary phase here also that is polar in the nature. Polar both are like interactions, and thereby you will see very runtime, that means they will travel very slowly. So in such cases the elution time taken for the process it is going to be very high, okay. So that is called as normal phase mode. And reverse phase mode, in this reverse phase mode means we are going to use the modified stationary phases, okay. Here in normal phase unmodified, the stationary phase whatever we are going to use that is as such, whereas in reverse phase modified stationary phase materials are going to be used, where the polar solutes run very fast. That means the stationary phase whatever it is there that is modified, that is completely converted as non-polar here, okay. Thereby what we are going to do, we are going to elute the polar solutes on the non-polar stationary phase at very faster rate. So if you find 50 minutes runtime in the normal phase mode, the same polar solutes you can run in the reverse phase mode within 5 minutes. That means very fast elution you are going to see in the reverse phase mode. Here whatever the mobile phase we are going to use, those solvents are going to be polar solvents, because stationary phase is non-polar here. Whereas in the normal phase you are going to see the stationary phase as polar and mobile phase as non-polar, okay. So that is going to be the difference between normal phase and reverse phase. And while separating the mixture of the compounds, you are going to see different n number of peaks in the chromatogram. So we require proper separation for closely eluting compounds. For that the criteria is resolution. So what is called resolution? The degree of separation, okay. So different analytes are going to be present in a given mixture. The different solutes may travel at different rates, okay. For that purpose resolution is very important. The degree of separation of different solutes, it is going to play a very important role, okay. And resolution can be improved by using, that means whenever closely eluting compounds are there, like if you get the resolution like this, that could be very good for the chromatogram. If you are getting the peaks like merged peaks or otherwise very closely eluting compounds are there, okay. So for that purpose base to base integration while we are doing, the peaks are not well resoluted in this case. In this case these are well resoluted. So that is called degree of separation of the different compounds, and this resolution can be increased by using different approaches. One of the simple approach is using the longer stationary phase, okay, and finer stationary phase or slower elutions, okay. So in this way that means runtime it could be more, but if you are going to use a proper longer stationary phase, instead of using 10 centimeter column, go with the 15 centimeters or 25 centimeters column. Longer stationary phases, okay, you can use. And finer stationary phase, that means the particle size it is going to play an important role. Generally for the chromatography techniques we are going to use 5 micron, 10 micron, 20 micron, particle sizes, and in those cases if resolution is not required, that means sufficient, then go with the finer stationary phase particle sizes. Okay, so go with the less 2.5, 1.7 micron, like that less particle sizes you can choose, so that you are going to get the required resolution. So this degree of the separation, it is according to the all the pharmacopoeias. If you see, the resolution should be always less than 2.0. It should not be less than 2.0 for any type of the method. Okay, so even though placebo peaks or any type of the other degradant peaks are also there, then the two different peaks should be separated by factor of 2.0. Okay, resolution is unitless and it can be calculated with a specified formula. According to the pharmacopoeial limits, more than 2 it is required between any closely eluting peaks. Okay, so this is one of the major and basic term in the chromatography, and some of the chromatography techniques like TLC, thin layer chromatography, we are going to come across the factor that is called as retardation factor, or we are also going to call this one as a retention factor. So RF value. Okay, so this RF value is nothing but the retardation factor or retention factor. So how it is going to be calculated? That is distance travelled by the solute divided by distance travelled by the solvent, because in the thin layer chromatography we are going to use different TLC plates. Okay, they are going to be 20 by 20 centimeters, 5 by 10 centimeters, 5 by 20 centimeters, 10 by 20 centimeters, like different types of the TLC plates we are going to use it. And spotting of the sample, it can be done once they start traveling after putting everything in the TLC chamber in the mobile phase. Okay, saturated mobile phase TLC chamber, we are going to put it, the traveling of the solute along with the solvent you are going to observe. Okay, so whenever we are going to see different spots on these TLC plates, then you are going to calculate the RF value for those identified marks. Based on that RF values, we are going to identify the alkaloids or amino acids which are present there. Okay, so these RF values are also going to be specific values are going to be given. Based on that, we are going to identify what are the components present in the given mixture. So in this way, the chromatography terms will help you in identification of the compounds. Now let us see the some other important classification of the chromatography techniques. So in the chromatography, we are going to observe the separation of the compounds and we can identify the compounds, and in this we are going to use different approaches. For that purpose, let us see the classification of the chromatogram. So this classification is also based on the 3 factors. Okay, so if you observe the first one, on the basis of interaction of the solute, that means whatever the analytes are there, the interaction of the solute towards the stationary phase we are going to use. Okay, on the basis, the chromatography has been divided into adsorption chromatography, partition chromatography, ion exchange chromatography and molecular exclusion chromatography. Okay, so adsorption chromatography we know that is solid stationary phase and liquid mobile phase you are going to see, and in case of the gas chromatography also GSC it is going to be there, but gas means again that is going to be under different classification. Okay, so just we can say adsorption between solid stationary phase and liquid mobile phase. Partition chromatography, this partition means both stationary phase as well as mobile phase are going to be considered as liquids here, because in the stationary phase if you observe the supporting medium, it is going to be there, that is going to be coated with a liquid material. That's why the separation it is going to take place between 2 liquid phases. Okay, here the partition principle come into the picture. Next, ion exchange chromatography means ions based on the charge of the compounds. Okay, so the exchange of the ions it is going to take place, and molecular exclusion, basically the size of the major polymers are going to be there, how they are going to having the interaction of those polymers towards the stationary phase. Based on that, high molecular weight compounds are going to be separated or low molecular weight. It all depends on the type of the column we are going to use. Okay. So this is basic of the interaction of the solute towards the stationary phase. That is the first classification. And second classification, if you see, on the basis of chromatographic column, what type of the column we are going to use. So if you see, column chromatography, thin layer chromatography and paper chromatography. Okay. So column chromatography means you are going to see the all the liquid chromatography, GC chromatography, everything. That means a column that is stationary phase, that is fixed. Okay. Stainless steel columns or whatever the capillary columns we are going to use. In this case, proper column it is going to be used in this case. Okay. Whereas thin layer chromatography means the stationary phase we are going to coat on a plate. That means thin layer, one thin layer of the stationary phase, it is going to be coated on a plate. So those TLC plates are going to be used. And here paper chromatography means the cellulose papers are going to be used as stationary phases. Okay. So these types of the column we are going to, based on the different types of the columns, the classification has been in 3 ways. Next, third classification on the basis of physical state of the mobile phase. That means in what state the mobile phase it is going to be used. Sometimes we are going to use the liquid mobile phase, that is called as liquid chromatography, and in gas chromatography if you see the mobile phase, here we are going to call that mobile phase as carrier gas. Okay. So gas chromatography is one type of the chromatography techniques, and affinity chromatography. Okay. So in this affinity chromatography we are going to use different types of the immobilized phases. Okay. Resinous materials we are going to use, and finally supercritical fluid chromatography. So in this technique the mobile phase it is going to be a fluid, not like liquid or not like gas. Okay. It is going to be a fluid. So that's why it is called as supercritical fluid chromatography. Okay. So this is the classification of the chromatography. Now let us see one by one the basic of each chromatography technique. So if you observe this this picture here, this is adsorption chromatography related. Okay. So in this, if you observe the adsorption chromatography, the principle involved in this adsorption, it is going to be based on the solute particles. That means whatever the analyte, it is having more number of the solutes. Okay. Different n number of mixture of the compounds are going to be used, and in this major adsorption it is going to takes place means the solid support whatever it is there. Okay. So let us say this is a solid stationary phase, and the particles whatever these are there, these are the solute dissolved in the liquid phase which are coated on the surface of the solid particles. Okay. So these are the different solid particles presented, and whatever these particles are there, they are getting interacted with the stationary phase. Okay. Majorly principle of separation means whatever the mobile phase we are going to use, either a liquid mobile phase or a gas mobile phase, the solute it is getting adsorbed onto the surface of the stationary phase. That stationary phase it is going to be a solid stationary phase. Okay. These solute particles are getting adsorbed on the surface. So this is a surface adsorption. It is going to takes place. The mobile phase could be a liquid mobile phase or a gas mobile phase also, but the adsorption term it is going to be categorized according to the stationary phase only. Okay. And here we can use different types of the mobile phase in order to take away these solutes from the stationary phase, and these solute molecules are going to be directly bound to this surface of the stationary phase. Okay. So this phenomena it is going to be called it as adsorption chromatography. Now let us see the partition chromatography. Partition chromatography, as I told you, the supporting medium it is going to be there like a solid stationary phase. Okay. So that supporting material it is not getting involved in the any type of the interaction. Whatever the coating material, that is a liquid coating material which is coated on this supporting material is going to act as a stationary phase. Okay. So then that coating material and mobile phase. In the mobile phase we are going to use the liquid. The separation it is going to take place in between these two phases. Then the principle of separation it is going to be called as partition chromatography. Partition component of the sample between the that means the distribution it is going to takes place between the two liquid phases. Okay. So here the stationary phase whatever we are going to use, that is nothing but a liquid stationary phase only. Okay. And the mobile phase could be either a liquid or gas, anything that takes place. So in column chromatographies mostly you are going to see like in HPLC and GC. Okay, GC also GLC, gas liquid chromatography. So in these two cases you are going to find this partition as the principle of separation. So based on the thin film formed on the surface of this solid support by liquid stationary phase, the equilibration of the solute it is going to take place between the stationary phase and the mobile phase. Okay. Another type of the chromatography technique that is called as ion exchange chromatography. So based on the exchange of the ions, because if you see the mixture may contains both positive charged ions as well as negative charged ions also. So if you observe the positively charged protein whatever it is there, it binds to the negatively charged, opposite attractions you are going to see, and negatively charged protein also it is going to be attracted towards a positive charge. So whenever you are going to observe this ion exchange chromatography, that means exchange of the ions it is going to take place, means the resins whatever the stationary phase we are going to use, that is going to be very very important. That resin stationary phase used to covalently attach these anions or cations onto it. Okay. So majorly if you observe this exchange of the ions, so anions with the anions, cations with the cations, already in the resinous material it is going to be occurring. So wherever the solute ions of the opposite charge in the mobile phase liquid are attracted to the resins by the electrostatic force. Okay, here the electrostatic force it is going to play a role, thereby the exchange of the ions it is going to takes place. Okay, and this ion exchange mechanism based on the respective charges. Okay, so positive charge it is going to bind to the negative charge means bind to the positive charge. So based on the separation respective charges these are present, and electrostatic forces wherever these are present, it is going to play a very important role. And here if you find the adsorption of the molecules to this support, okay, that means the solid support we are going to use here. Okay, so it is going to be driven by the ionic interactions. The interactions ions are going to be there. Okay, so definitely the ionic interactions between the oppositely charged ion groups in the sample molecule and the functional ligands on the support, it is exchange of the ions it is going to takes place. Okay, so that is the basic thing, and adsorption it is going to takes place here. And the strength of the interaction, that means how the exchange of the ions it is going to take place, means the strength of the interaction if you are talking about, it is determined by the number and location of the charges. Okay, how charges it is going to be there on the molecule and the functional group. The resin it is going to be very very important thing here. Okay, which type of the resin you are going to use, thereby the electrostatic forces will come into the action, and you are going to see exchange of the ions it is going oppositely charged, okay, resins it is going to takes place. And next type of the chromatography technique, that is molecular exclusion chromatography. Okay, by the name itself some of the techniques are going to be defined, and molecular exclusion based on the size, it is also called as actually gel permeation chromatography or gel filtration chromatography. Okay, so gel, because the stationary phase whatever we are going to use, those are soft gels we are going to take it. Okay, so if you simply filter it, that means the filtrate it is going to be coming out and the residue will be retained on the top, so that is called as filtration. Okay, here also the same gel we are going to use, whatever the mobile phase we are going to use, that is with respect to aqueous mobile phases if you are going to use, then the technique it is going to be called as gel filtration chromatography. Immediately it will come down, whereas gel permeation means we are going to use the organic solvents, okay, as the mobile phase. So in molecular exclusion chromatography we can easily separate by the molecular sizes, okay. That means filtration, you can say the whatever the pore size it is there for the gels, if it is more than the pore size it will retain on the top, similarly less means it will come down. And here in the molecular exclusion chromatography it lacks the attractive interaction between the solute and the stationary phase, where in the ion exchange chromatography you are going to see the electrostatic forces are going to be there in order to exchange of the ions it is going to take place, whereas in the molecular exclusion no attractive interactions, okay, no interactions are going to be present in the solute and the stationary phase. Whatever the liquids or gaseous phases we are going to use in this case, it going to passes through a porous gel like stationary phases we are going to use, which separates the molecules according to their sizes, okay, more than the pore size or less than the pore size, it depends on that. And the pores whatever we are going to use for these gels, normally these are small and they are going to exclude the larger solute molecules, but whatever those particles are there, they allow the smaller molecules to enter the gel. To enter the gel it is going to be present, whereas it is causing them to flow through a larger volume. This causes the larger molecules to pass through the column at faster rate than the smaller ones, okay. So in this way the based on the size you can separate that, and whatever the it is size based on basically the size. So generally it is a low resolution technique, okay. The resolution could be poor in this case, but if you are going to use some of the polymers, okay, mostly the mixture may not contain more than required polymers, okay, 1 or 2 are going to be there. So it is better going to use for larger molecules and smaller molecules. Definitely these can be separated very easily by these soft gel filtrations and permeation techniques, okay. So another chromatography technique, that is column chromatography technique, which is going to be widely used for the department like pharmacognosy, right. So because plant extracts, wherever they are going to get it, they can separate these all these extracts and whatever the chemical constituents are going to be expected in those constituents, okay, they are going to separate by this column chromatographic technique. And in this column chromatography, if you observe the entire column, first of all we are going to set up, that means whatever the stationary phase in this it is, we are going to arrange that stationary phase initially. For that we need a glass columns which are having the provision for the flow of the mobile phase, like a burette how we are going to have the knobs and all these things, okay. So from the above side we are going to pack the stationary phase, and the stationary phase also we are going to use by either wet packing method or dry packing method, but preferably we can go for the wet packing only. And for loading of the stationary phase also we are going to use number of compounds like silica, as well as silica beads are going to be used, as well as alumina activated magnesium silicate, okay. So all these talc, starch, these are also specifically for some types of the sugars and lipids. We are going to use different types of the stationary phases here. So whatever we are going to use the stationary phase specific to the compound, but initially we have to load the stationary phase, then it in the uniform manner. Afterwards we are going to load the sample, okay. So then we will allow it for some time. Afterwards we will start the mobile phase, that means whatever the solvents we want to use, we will start the elution process, okay. So in this you can observe with the clear cut color differences. So initially the blue color entire one you are going to call it as a stationary phase, then sample has been already loaded, this is in the green color, okay. So once we start the elution process by pouring the mobile phase, then automatically it takes some time and it travels through the stationary phase, and the separation of the compounds you are going to observe with the different colors. if these are the colored compounds. If not, whatever we have to do means we need to collect those fractions. Okay. Afterwards, we are going to identify them and extract them. Those fractions are going to be extracted and we will identify what are the chemical constituents present in them. For isolation and characterization, this column chromatography, it is going to be highly useful. Okay. And most of the columns you are going to observe for the colored compounds means the colored bands you are going to observe in the column itself. Okay. So, the eluted molecules of different colors we can collect very easily. If colored compounds are not observed means we can collect the fractions and then we are going to extract them and identify the compounds. So, in this column chromatography, whatever the stationary phase we are going to use, that is a narrow bore column we are going to first of all load, through which the mobile phase, the first step, second step, like this, third, fourth and fifth steps. Okay. So, based on the number of constituents present in that particular sample mixture, okay, we are going to collect those fractions. We are going to add the mobile phases with increasing polarity, or if the samples are different polarity means we are going to change the order of the polarity of the solvents. Okay. So, under whatever the gravity, because we are pouring the mobile phase from the top, and due to the gravity only the mobile phase starts travel through the stationary phase. Okay. So, in this way column chromatography it is going to work out well, and this is also going to be highly useful for mostly selected compounds. Okay. And coming to this another technique, nothing but the paper chromatography. Okay. So, in this paper chromatography, if you observe the most of the papers whatever we are going to use, okay, these are made up of the cellulose. Okay. Cellulose pores are present. In that pores, the whatever the mobile phase it is going to be there, it is traveling along with the solute. Okay. And initially the paper has to be taken, and this is the paper represented. Okay. First of all, we are going to spot the sample mixture. Okay. Afterwards, we are going to put the paper in the mobile phase. Okay. And through the pores present in those cellulose papers, okay, the solvent is going to travel through the pores, and here this is actually ascending type of the paper chromatography, because the mobile phase is kept at the bottom. Okay. And solvent also will flow along with the samples also. So, clear cut you can see the separation of the compounds if these are the colored compounds, or otherwise you can after development of this chromatogram. Okay. So, you can take it the paper, and by spraying some spraying reagents also you are going to use the identify what are the different components present. Okay. And here the whatever the papers we are going to use, compulsory they have to be inert in the nature, and here the principle majorly involved in the separation of the compound, that is nothing but the partition, because the cellulose paper it is present and pores are there. The pores present in that cellulose paper, it is going to act as a stationary phase. Okay. So, that is why it is majorly the principle involved in this paper chromatography considered as a partition chromatography. Okay. So, either it could be a ascending chromatography or descending chromatography, and sometimes we are also going to use the radial chromatography also. Okay. So, in the paper in the center itself we are going to put a wick, and that wick is placed in the mobile phase chamber, and entire circular paper we are going to use it, thereby the chromatogram it is going to be developed in a radial way. Okay. So, radial way you are going to see like this. So, one wick will be present, this is inserted in the mobile phase. So, at the top you are going to put the paper and the wick is dropped down. Okay. So, the mobile phase will move along with that, and you are going to observe the radial type of the chromatogram. So, in this way paper chromatography we are going to use three types: ascending chromatography, descending chromatography, is radial chromatography. And whatever the papers we are going to use, okay, these are going to be actually one dimensional, and sometimes we are going to use the two dimensional chromatography also we require. Okay. Once the development has been done, that means still we are expected that the compounds are not yet separated, then again the papers are going to be dimensions has been changed. Okay. So, once the ascending is over, then again we will change the direction of the paper to the right angles to that, again two dimensional chromatography also we can perform. Okay. And here we can use the different types of the organic solvents or waters, aqueous solutions, okay, ternary phase, mobile phases, as well as whatever the composition it is, we are going to use in the paper chromatography based on the nature of the compounds we are going to separate. Okay, so similar to the paper chromatography, thin layer chromatography is also going to play the same role, but in thin layer chromatography what we are going to do is just we are going to take the glass plates here instead of the paper. In the paper chromatography we are going to use the cellulose papers, okay, but in case of the thin layer chromatography means we are going to coat the stationary phase on the glass plates. So these glass plates are going to have different dimensions, 10 by 10 centimeters, 10 by 20 centimeters, okay. So like this you are going to observe the different sizes of the plates, and the TLC chamber is also available in different dimensions also. So here also we are going to put the mobile phase at the bottom of the chamber or sometimes at the top of the chamber. So in this TLC also we are going to use ascending type of the chromatography as well as descending type of the chromatography also we can perform, okay. Same as that of the paper chromatography, TLC is also going to be performed. After the development of the chromatogram, we can take out those TLC plates from the chamber, then we are going to calculate the RF factors. What is RF factor? Means retardation factor, okay, distance travelled by solute divided by distance travelled by the solvent. So based on the RF values we are going to assume that, okay, so which is having alkaloids or which are having amino acids, like that we are going to identify, and we will confirm by using some of the spraying reagents also, okay. And thin layer chromatography we are going to use different types of the stationary phases, okay. Stationary phases means silica gel we are going to use most of the case, as well as alumina, charcoal also we are going to use, okay. And activated silica, it is also going to be used, talc is also going to be used, and all these stationary phases are going to be packed, that means they are coated on the plates having thickness of the only very less thickness, that is only up to 250 microns only, that thickness has to be there, okay. And whatever the stationary phase we are going to use, okay. So if you are going to use the silica gel, it may have different grades of the silica gel also. Silica gel G will be available, F will be available. F means fluorescent grade. So after development of the chromatogram, you can directly take out the plate and you can keep it in the UV chamber, okay. So for that purpose you are going to use a silica gel F. F means fluorescent silica gel, okay. Under the UV light it will fluoresce, that means any fluorescent compounds are there, you can easily identify in the UV chamber. So in that way the compounds which are having more affinity towards the stationary phase, they are going to have the more binding towards the stationary phase and they travel very slowly, and the compounds with having lesser affinity towards the stationary phase will travel very fast, okay. And we are going to use here also different combinations of the mobile phase, and according to the affinities we are going to observe the compounds separation, okay. So next technique, if you see in case of this chromatography, that means already we have discussed this some of the chromatography techniques, okay. One more important chromatography technique, that is gas chromatography. In this gas chromatography already we have seen in case of the classification itself only the mobile phase, that means here the mobile phase we are going to call it as a carrier gas, okay. That should be an inert gas like helium, hydrogen, nitrogen, these are going to be used. And gas chromatography, this is also called as gas liquid chromatography, because here also you are going to observe the separation of the compounds between two liquid phases. So that's why the main principle of separation here you are going to find, that is the partition chromatography, okay. Partition equilibrium of the analyte between a solid stationary phase, that means solid, it is not completely solid here. Gas liquid chromatography means GLC, the supporting medium, a liquid coated stationary phase, it is going to be present, okay. But so solid support, again the binding phases are attached, that's why it is called as the gas liquid chromatography. In case of the gas solid chromatography, that is called as GSC, you are going to take the principle, that is adsorption chromatography, okay. So here whatever the stationary phase columns, that means in partition chromatography also we are going to use, in case of the GC, very lengthy columns we need to use, okay. Capillary columns, packed columns, and wall coated columns, support coated columns, like this different types of the columns are available for the GC. And very small diameter, less than 1 mm diameter columns we are going to use, very capillary columns actually we are going to call them as, okay. And so on the solid support, even though we are going to use the coated material as stationary phase, sometimes the separation of the compounds, it is going to be highly difficult, because in gas chromatography there are some limitations. All the compounds cannot be separated by gas chromatography, okay, like flavonoids, residual solvents, because in this gas chromatography also high temperatures are going to be used. And here whatever the mobile phase, that means the carrier gas we are going to use, that should be an unreactive gas. And flow control of the carrier gas is also very important. And compulsory the inert gases like helium and nitrogen are going to be used. Whenever hydrogen is also going to be used, in such cases the flow control is very highly precautionary measurements we are going to use, okay. But in GLC the partition, it is going to be the principle involved, whereas in case of the GSC, adsorption is the principle involved, okay. And this is the simple schematic view, that means not the schematic, outline of the HPLC, high performance liquid chromatography, okay. It is a single stack HPLC, liquid chromatography. In this you are going to see the, first of all, the solvent reservoirs, solvent bottles will be present. Afterwards degasser it is going to be there. Then afterwards you are going to observe the pumping systems, okay. And then this is the degasser and pumping system, it is going, pumps are going to be present. So this is the injector, okay. So in this we are going to put the all the HPLC vials. And this is the column compartment where we are going to place the column. And this is the column entire, it is maintained under a certain temperature also. So column oven it is present, we can maintain up to 60 degrees also, 80 degrees also. And afterwards you are going to see the detectors, okay. So detectors, you may have 1 or 2 types of the detectors are also going to be attached to the liquid chromatography, whereas in case of the GCMS also you are going to see the different attachment of the detectors, okay. And in GC gas chromatography we are going to use flame ionization detector, thermal conductivity detectors. Similarly in HPLC also we are going to use the UV detectors as well as fluorescence detectors, RAD, refractive index detectors, okay. So and mostly LCMS means mass spectroscopy. Along with the mass spectroscopy, UV it is also going to be present along with the mass spectro. Additionally, mass spectroscopy it is going to be attached to the liquid chromatography, okay. So then the technique becomes hyphenated technique. So in this HPLC, if you observe whatever liquid chromatography, whether it is HPLC or GC, separation it is going to be taken place on the column itself, okay. And the mobile phase whatever we are going to use, that is a liquid. And here the complete principle involved in this, that is partition chromatography, okay. So based on the partition coefficient, the distribution of the compounds it is going to takes place. And these are the column, that means here we are going to use a column, not the like thin layer chromatography, all these are not using the column, only stationary phase that is required. But here in HPLC or GC and column chromatography technique, if you find, we are going to arrange a column, okay. And HPLC you can perform the column chromatography in a plane wise also, that means already manufactured stationary phase has been already packed in a stainless steel columns are available, okay. So these are commercially available columns we are going to use. And the particle size of the stationary phase is also going to play a very important role. And these small particles, because of the very less particle sizes, okay, we are going to face the high pressure in the HPLC system as well as GC also, okay. So that's why it is called as high pressure liquid chromatography as well as high performance. Due to the less particle size itself, it is going to give you the clear separation of the compounds, okay. And mostly the HPLC technique, whatever we are going to inject the sample, okay. So through the injector we are going to give the sample, and all the HPLC vials are going to be present there. And here the resolution, it is also very important, as well as whatever the samples are there, these are going to be injected manually, as well as auto injectors are also available. And whatever the stationary phase, based on the normal phase columns we are going to use, or reverse phase mode. Okay, that means based on the type of the compounds only we are going to select the mode of separation. In normal phase you want to perform, or reverse phase you want to perform. Okay, and whatever the stationary phase it is, that is going to play a key role in this separation technique. Okay, and different particles are also available, 5 microns particle sizes, as well as 1.7 micron particle sizes are also going to be available for the usage of the HPLC column. And from the past 3 to 4 decades, HPLC is playing a very key role in the separation of the pharmaceutical field, whereas not only pharmaceutical field, in some of the most of the analytical laboratories also this is a widely used equipment, and the technology is going to be developed, and now we are going to use the ultra performance liquid chromatography also. That means the column, it is going to play a different scenario there. Okay, so all these liquid chromatography techniques are going to be based on the plate theory and rate theories, based on the flow rate as well as the number of plates available. Okay, we know that HETP means height equivalent to theoretical plates, right? So this height equivalent to theoretical plates means, actually this theoretical plates are very hypothetical type of the statement we are going to say, whatever the columns we are going to use in case of the liquid chromatography. So hypothetically it is assumed that the stationary phase, if it is having the more number of the plates, means the efficiency of the separation, it is also going to be more. Okay, so height equivalent to theoretical plates, so this is reversely proportional to the number of theoretical plates. If the height is very less, that means the numbers are going to be more. Okay, so if the height equivalent to theoretical plates is very less, means number of theoretical plates are going to be more. So this actually the formula it is also there in order to calculate the HETP, that is L by N. L is nothing but the length of the column. Okay, so according to the pharmacopoeias also, if the number of theoretical plates is more than 2000, then the method whatever we are going to propose by the liquid chromatography technique, it is the highly efficient method. Not only number of theoretical plates, symmetry, it is also going to, symmetry of the peak, it is also going to be approximately equal to 1, as well as tailing factor. Okay, so all these factors are also going to be playing a very key important role. Tailing factor should be less than 2.0, as well as resolution, that means more than one compound it is there, so obviously the resolution should be more than 2.0. so like that some of the important parameters are there in order to perform any type of the separation on the liquid chromatography methods. Okay, and here if you see another type of the chromatography technique, apart from the liquid chromatography and gas chromatography, we are going to have the one more technique, that is called a supercritical fluid chromatography. So in this nothing more difference, but only the mobile phase, whatever the mobile phase we are going to use, it is a separation technique in which the mobile phase is a fluid above. Okay, not the liquid and not the gas, it is going to be a fluid above that. Okay, and it is going to be very depending on the critical temperature and pressures are very important. Okay, because the mobile phase, it is just a fluid above, that's why supercritical fluid chromatography. Okay, very little applications we are going nowadays, because still research is going on, that's why we are going to see very little applications on this supercritical fluid chromatography, but we can perform the analysis on this also. And finally the another last chromatography technique, that is nothing but the affinity chromatography. Affinity means the compounds which are having affinity towards the stationary phase. Okay, that means they are going to have some of the interactions between the stationary phase. That means here if you observe the affinity chromatography based on the non-covalent interactions. Okay, that means these are not tightly bounded, like ion exchange chromatography means electrostatic forces are going to be there, the exchange, complete exchange, it is going to take place. Okay, similarly molecular exclusion means no electrostatic forces, only the based on the size only the separation it is going to take place. Whereas liquid chromatography, gas chromatography means partitions are going to take place, and adsorption, that is entirely getting adsorbed on the surface of the stationary phase. And this affinity chromatography is entirely different. That means here the interactions are going to be there, but non-covalent interaction between the analyte and the specific molecules. What are those molecules? Means like immobilized ligands we are going to use. So most of the enzyme linked, okay, SS, immunoassay methods, whatever we are going to found. So those are called as the affinity chromatography methods. Okay, so here whatever the affinity ligands, okay, we are going to call them as the molecular recognition groups. That means the compounds are having affinity towards that. Okay, so like a drug and receptor, how these are going to have a affinity similarity. Okay, similarly here also, but these are going to be having the non-covalent interactions. Okay, but whatever the molecular recognition groups are there, initially we are going to take the covalently attached to the some of the basic beads like cellulose beads or agarose beads, we are going to use it. Okay, these are having the affinity ligands, and between these ligands and the analyte we are going to see some of the interactions. Those are the non-covalent interactions. Okay, and most of this affinity related chromatography, it is going to be used. That means binding as well as removal, it is also going to be possible. Reversible reactions is also going to be possible towards that. Okay, majorly if you observe the mechanism of retention for this affinity chromatography, that means interactions with the highly specialized molecular recognition systems, nothing but the ligands. Okay, so which are attached to the stationary phase. So once they get attached, they can be removed also. So reversible reactions are also going to take place. For that purpose, we are going to use some of the resinous materials. Okay, and here we are going to use the mobile phase, whatever in the affinity chromatography, it is going to play some of the two different types of the roles. Let us see what is that. So here the mobile phase support the strong binding of the analyte. That means whatever the mixture of the sample mixture we are going to take. Okay, so the mobile phase support the strong binding of the analyte molecule towards the ligand. Okay, and one more characteristic, that is it weakens and eliminate the analyte ligand interaction. Okay, so two roles it is going to play. That means once we will add the sample to the resinous stationary phase, then the mobile phase initially it will help to binding of the analyte towards the stationary phase. So once it is done, then again it is going to, by usage of the different polarity strengths of the mobile phase, it weakens that interaction and eliminate the analyte and the ligand bonding. Thereby you are going to retain the compound on the resinous material. Afterwards we are going to do the elution process. Okay, thereby we can easily identify and we can easily separate the compounds also. But affinity chromatography, it is going to be basically used for the immunoassay methods. Okay, and these are some of the points related to the chromatography. That means basics of the chromatography, different types of the chromatography, and the terms we are going to use in case of the chromatography separations. Okay, hope you understand this session very well, and let us meet with some more new topics in our Pharma Thunderstorm series. Thank you students, thank you for attending.